So a particle starts off with a velocity of 20 meters per second at an angle of 30 degrees to the horizontal. Okay. A, we're going to say how long does it take to reach its maximum height? B, we say calculate its flight time. Right? Calculate its flight time. Then C, calculate the maximum height reached. Then D, how far from the start point does it hit the ground? Right? Okay, like this. Now let me look for my calculator. I don't know where my calculator is. Okay, I got it. So I hope you have copied that question because I haven't copied. My question is only on the board. So you'll be able to remind me of the questions, right? So I'm going to erase this. So we need to know that the initial velocity is equal to 20 meters per second and the angle is 30 degrees to the horizontal. So it's like something like this, okay? Something like that, right? So the particle starts off with a velocity of 20 meters per second at an angle of 30 degrees, right? So we want to find the time it takes for it to reach the maximum height, okay? How long does it take to reach the maximum height? Now, we're going to use the equation for time it takes to reach the maximum height. Remember, I said that Tmax is equal to what? V initial sine theta, okay, divide what? G, okay? V initial sine theta divided by G. So this is going to be our V initial, which is 20, okay, multiplied by sine 30 divided by 9.81. Okay, so this is going to give us what? I'm going to get 20 multiplied by sine 30 divided by 9.81. So this is 1.02. Okay, 1.02 seconds. Okay, any problem with that one? Do we have any problem? Then, but this says calculate the flight time. So flight time, remember, if we cut this graph into two, this part, this is Tmax, okay? So for it to reach this point, that is Tmax. Now this side and this side are equal, so this side also that is going to be Tmax, okay? So in other words, the total time it takes is just double of Tmax, right? double of T max. So in other words, we are saying that T range, flight time is T range, the time it takes to cover the range from there up to there. So T range, okay, say that T range is equal to 2 multiplied by T max, okay, which is going to be equal to 2 multiplied by 1.02, which is going to be equal to what? Multiplied by 2, that is going to be 2.04 seconds. Okay, but that should be, yes, 2.04 seconds. So that is the time it takes for it to cover the entire journey. Should I call it journey, right? Then calculate the maximum height reached. Okay. So what is the maximum height reached? Remember, this one here at this point, that is, in other words, we're trying to look for the value of y. So here we have x comma y, okay? We have x comma y. So we're saying that y maximum is going to be equal to what? It's going to be equal to, it's what? V initial, okay? V initial squared, right? Then what? Sine 2 theta. Okay. Okay, let me do this. Let me try to derive that equation again. I usually forget those equations, but I have to derive them. So we say that it's in V initial sine theta, okay, multiplied by T max, right? By T max, then minus half GT max squared, okay? So if we want, we can derive the equation, but since we already have the value of T max, we can just get it and put it in there. So this is going to be equal to V initial is 20, okay, multiplied by sine 30, then multiplied by T max, which is 1.02 minus what? Minus half multiplied by 9.81 multiplied by 1.02, okay, like that. So this is then going to give us what? It's going to give us, so that times, let's say times 10, then minus 2.5, minus 9.81 by 1.02. So this is 5, okay, 5.19, 5.8, 5.19 meters. So the maximum height from there to there, that is 5.19 meters. Okay. Then we calculate the furthest point. Okay. How far does it go from the start point before it hits the ground? So how far? Okay. In other words, we're talking about this point here. Okay. So that is x, the value of x there. So remember, we said that the x coordinate at any point, is calculated using the formula x is equal to v initial cos theta multiplied by what? T. Okay. Now in this case, we are trying to look for x range. So x range is equal to v initial cos theta multiplied by T range. Okay, which is going to be equal to V initial is 20 multiplied by cos 30, then multiplied by what? T range we calculated that it was 2.04. So which is going to be equal to what? That would be 20 by cos 30, that then multiplied by 2.04, which is 35.3. Okay, this is 35.3 meters. So the distance from here to there is 35.3 meters. Okay, so I'm going to give you an assignment. I'm going to give you a question that you can answer in your own time, and then we're going to go through it together next time. So, but I want you to give me the answers tomorrow. Okay. So we're going to. Can I erase this? Probably yes. Can I erase? Okay. So we say question. We say during a football team, a football match, let's say between Zambia and let's say Zimbabwe. A Zambian defender, okay, kicks the ball from the 18 meters mark on their side at let's say 22 meters per second. So let's say at 20 meters per second at an angle of 11 degrees to the horizontal. Okay. Calculate a mm, how long the ball takes before reaching its maximum height, being how far from the Zambian goalpost. Okay, how far from the Zambian goalpost the ball will be when it reaches the maximum height. Okay, going to erase on top here. C, the time taken for the ball to reach the ground. D, how close the ball will be from the opponent, from the Zimbabwean goalpost when it hits the ground. Okay, now I have given this question in this way because I remember when I was in first year, that was in 2014, term 1, our test for term 1. If you remember in 2014, that's when we had, there was World Cup. There was World Cup in 2014, right? And the question that came, it was for, was it Brazil and Germany? If you remember, there was a, I don't know if you guys can remember, if I told you used to watch soccer that time. There was a game between Germany and Brazil, and I think Germany won. Was it 7-1, something like that? Yeah. And they got a question like this, although I've not obviously phrased it exactly the same way, but it was something similar. Okay. Let me add one more question. So we're going to say derive the trajectory equation for the ball. Okay, derive the trajectory equation for the ball. Right? So that is going to be your question that you're going to feast on tonight and tomorrow, and then you should send your solutions. Okay, so I'll end the recording here.